Looking at the limit as t approaches 0 of 8 to the t minus 5 to the t over t, we see that we have to apply rules for differentiating exponential functions with a base other than e. With that in mind, I'd like for you to pause the video and see what you can do with this. No, I didn't say it, but I hope you did take the initial step to check to see that L'Hopital's rule does apply. And in the numerator, 8 to the 0 minus 5 to the 0 gives us 1 minus 1, or 0. Denominator 0, so we do end up with a 0 over 0 indeterminate form. That aside, now we apply L'Hopital's rule, little h over the equal sign. Derivative of 8 to the t is natural log of 8 times 8 to the t. Likewise, we have minus natural log of 5 times 5 to the t. Denominator being t gives us a derivative there of 1, and direct substitution yields natural log of 8 minus natural log of 5, which can also be expressed as the natural log of 8/5. Next, we're going to see the limit as x approaches a from the positive side. And folks, as soon as I see that, I start wondering, why is it from the positive side? Moving on, though, we've got the cosine of x times the natural log of the quantity of x minus a. Well, there it is. A from the positive side because we have a natural log of x minus a. Anyway, cosine of x times the natural log of x minus a divided by the natural log of the quantity of e to the x minus e to the a. This one we're going to work on together. Folks, the problem here when we try to directly substitute happens with the log in the numerator and the log in the denominator. When we perform our initial check, we get the cosine of a times the natural log of 0 divided by the natural log of 0. I should note it's 0 from the positive side. We may recall that the limit as x approaches 0 from the positive side of the natural log of x is equal to negative infinity. And if you need confirmation on that, just draw a quick sketch of the graph of the natural log of x. So here we do end up with infinity over infinity. I almost wrote 0 over 0. And so L'Hopital's rule does apply. But I want you to notice something here. In our check, we were able to write cosine of a. Well, that's not a problem. For any number a, cosine of a is a finite number. And so I'm actually going to pull the cosine of a out of this whole mess. And I'm using a property of limits that says that the limit of a product is equal to the product of the limits, provided the limits exist. So I'm assuming that the limit for the natural log quotient exists. Anyway, now we have the cosine of a times the limit as x approaches a from the positive side, and I'm about to apply L'Hopital's rule, of 1 over x minus a, 1 over the argument for the natural log in the numerator, and then 1 over the argument for the natural log in the denominator, so 1 over e to the x minus e to the a times the derivative of the inside function. The derivative of the inside function is e to the x. Rewriting, this becomes the cosine of a times the limit as x approaches a from the positive side of 1 over x minus a times the reciprocal of the denominator, so e to the x minus e to the a divided by e to the x. I'm again going to just rewrite this. Cosine of a times the limit as x approaches a from the positive side of 1 over e to the x times e to the x minus e to the a over x minus a. And you might say, well, you didn't do anything. Well, not really, but I've changed the way it looks. I've put the e to the x minus e to the a as a numerator with a denominator of x minus a. Notice also that we have 1 over e to the x, which wouldn't be a problem if x is a. So another quick rewrite. You don't have to write all these steps, of course. We now have the cosine of a over e to the a out front. We still have this limit, though. Limit as x approaches a from the positive side of e to the x minus e to the a over x minus a. We can apply L'Hopital's rule at this point. However, I'd like for you to take a look at this limit. Does it look like anything familiar? Maybe pause it and stare at it if it doesn't. Here's the answer though. F prime of A is equal to the limit as x approaches A of e to the x minus e to the a divided by x minus a. And this would be true, well, it's as x approaches a from either the positive or negative side. And so it's true even if x is approaching a from the positive side. In this case, f of x is e to the x, which means that f prime of x is also e to the x. And so f prime of a is e to the a. So this whole thing becomes the cosine of a divided by e to the a times e to the a. The e to the a's, of course, divide out. Our answer here is the cosine of a.